Hi everyone. So it's nearly time to start. It's time to start. So I'm gonna talk about Tanker, and if you don't want to listen to me and follow at your own rhythm, you can download the presentation at this URL. It works. So a bit of presentation. First, everybody hear me correctly? It's all right, or should I speak louder? Like that? Oh, good. Blah, blah, blah. So I do Python development since 2006, and a few also SQL, web dev, sysadmin stuff, and general IT development. I'm also a long-time Triton contributor, so it's an ERP framework in Python, and I spend so much time on it that it probably skew me a bit on how I see development and how database should work, and etc. And currently, I'm an admin employee. I'm mainly consultant for NG, which is an energy provider in both France and Belgium mainly. And Admio is hiring, so we are searching for Python developers. So if you look for a job, you can ask us. So I will start with a bit of context about Tanker to give an idea of why it was created, and then I will show some example how it works and tell some details about how it works and how to use it, and then a few slides about the future of Tanker. So mainly what I still don't like about it, what I would like to implement, and some ideas. So as I said, we are consulting mainly for NG, and we work with a lot of external data. So we are downloading data from web services, we are downloading CSV on the web, or we are scraping websites, or FTP files and stuff like that. Those data are most of the time heavily denormalized, so completely the opposite of what you want in a database. We have most of the time no explicit ID to identify the record, so we don't know if it's the first time we see a value or if it's an update of an existing value. And sometimes you have an ID, but it can be unreliable, or sometimes you don't even know what can be interpreted as an ID. Yes, and as I said, we are scraping website and CSV, Excel, etc. And when it's not external data, when it's data maintained inside the company, everybody loves to work with Excel, or everybody, at least the non-developers. And it's the same issues. We don't have any IDs to work with in Excel. We could add some, but it creates other issues. And generally, we have no metadata for that. And more about the context. So this is more about how we get the data and what we do with those data. We have a few amount of business data, so concept that we have not much data with a lot of logic about it, and so as I said, for example, we manage data about power plant, fuels, shipments, and we maintain a lot of time series. So like weather forecast, plant production, and stuff like that. So it's mainly time series. We don't care about one line and alone. We care about a lot of data to compute averages, sum, and stuff like that. So we are far away from an ERP or a blog application or stuff like that. So the first question would be, we have ORMs in Python, so we could use them to write those data in databases. But as I said, we work with a lot of time series and stuff like that, so we don't need to instantiate an object for each timestamp. It's not really useful. But we need other type of features than what traditional ORM offers. And I like, and you should like the relational model, and you don't always need object in Python. You can work with kind of relational data also in Python. So, as I said, we have no IDs to identify records, but we have when you read all those records, you can identify them. When you have a weather forecast, you have a timestamp, you have a region where this weather forecast is done, and a temperature. So there is a way to identify stuff. There is a way to know if a data is new or old, or if it's an update or not. So all we miss is a technical support to do that. So the idea is, okay, let's enforce this way of working. Let's work with natural key for or business key for everything, and let's build on that. So I start with I will do the main example with the same set of data. So let's say we have incoming data looking like that. It can be a CSV file or coming from an Excel file. And so as you can see, we have different people that are members of different teams in different countries, and each of them has a code which can act like a reference or something like that. Yeah, and so it's a bit tricky because as you can see, we have different teams with the same name in different countries. So we'll see how it works with that. So in Tanker, how do you define your table? In the example, I show it with a YAML definition, but it could work with a simple Python dictionary. So I hope you know how YAML works, but if not, it's not difficult. So this will become a list in Python. So we have a list, and each list is a dictionary, and each dictionary defines the table we want to define, the column of the table, and an index. So how we identify something in this table. And so here this means we're going to create a table called team with a name, a country which reference a country column which reference the country table, and that will use the ID column of the country table. So it's a foreign key. Table country, it's even simpler. We only have a name column, and of course we index on that. And so all we have to do is define the member table, which contains the name of the member, the code of the member, and to which team this member is linked. And in this situation, we use the code itself as an index. So now we have defined the look of the database. All we have to do is to say which database we want to connect to. So it can be either SQLite or Postgres, the both backends supported by Tanker. And so here it's a dictionary saying which URI we want to connect to for the database, and then the schema. So this YAML def is the YAML we saw earlier. And then with that, we can use the connect method, which is context manager, and with that, we can create the table. The table definition comes from the config, and if the table does not exist, if a table does not exist, we create it, and then we add the columns. And something that can be tricky sometimes, you don't have to specify your table in a specific order. In the example, I create first team that reference a country team. In the example, I define first the team table that reference a country table, but it's not an issue. But there is no support for migration. So if you change the type of a column, it won't work. But if you add a column and rerun the create table, it will work. So how do we put content in the database now with Tanker? I show the countries here as a simple list of tuple. So it's your job to extract this information from your source. And then what we do is we instantiate a view object. So the first argument of the view object is the table we want to write to, and the second one is the list of columns we want to fill. So in this case, country CZ, name is the only column. So once the view is created, we call write, and it's gonna write the country for us and fill the name column. So quite easy. Same for teams. So it's really close. We create a view for the team table, and we say we're gonna map two columns now, the name column and then the country column. The country, as I told you, is a foreign key. And here we say we're gonna use the name column of the country to identify our record. So Tanker knows, okay, this string is going to be the name of a country, and I will maintain the foreign key in the team table for you. And so then we can write it like that. Yeah, I didn't explain yet. So the view object is close to the only object you really need in Tanker. You can see it as when you read data from the database, you can see it as a view, like a view table in a database, because you can use it to select which column you want to see. But here we also use it to to write. And yeah, so it's how you view your database and how you're gonna write in the database. So after those two steps are done, we can, so in this case with SQLite, we can use the SQLite command line to check what we have done. So we see we have our countries. The IT column was created for us with an auto increment. Same for the team. And then, oh, this is a wrong copy paste. And the foreign key here is filled by the correct countries. So as you can see, we have two blue teams in two different countries, but our index is built on those two columns, so it's not an issue. So how it works exactly? Because, as I said, the goal is also to batch a lot of write in one go. So in this case, I have 3 countries and 3 teams, so it's not a big deal, but the goal is to write 1,000 of values in one go. And the first implementation was trying to write in the database line by line, and it was super slow. So, so it works. How it works? So when you call write, the first thing we do is to create a temporary table. And this temporary table has no constraint, so there is nothing to check when you write on that. It's really a temporary place to put stuff. So we call copy from. So copy from is from the Postgres API. It allows you to kind of upload the CSV into Postgres in one go, and it's the fastest way to put stuff in Postgres. In SQLite, you can still write stuff line by line because you have no you have no cost to pay across the network, and you are on the same process, so it's fast. So once this temporary table is filled, we join this temporary table with the actual one. So let's say we want to fill teams. I don't know what happens. So this join will tell us which line of the temporary table is new and which line already exists in the real table, yes. And so we insert the new line and we update blindly all the other one. So when you upload, when you do a write with Tanker like that, you overwrite everything, or at least all the line. We don't try to say, oh, this line is completely equal, so we don't touch it. No, we insert and update everything. And then when this is done, we drop the temporary table and we are done. So it's a nice way to do the write in a batch with a temporary table, but still maintain all the features like foreign key resolution. So when you write, when you do a reference to Belgium or France, we know which ID it is and stuff like that. Should I do something to stop that? I close it? Like that? Or I can, of course, sorry. So now we have stuff in the database, so we can read it. So, yeah, so still with the connect context manager. So as you can see, it's the same view definition. So it's still there, but it could be the same object if you want to keep the same object. But so here we say we want the name column and the country column, but you give me the name of the country and not the ID. I don't care about it. And so the .read give us, so does execute the query and give us back the Postgres cursor or the SQLite cursor. So you can loop on that, or you can do .all, and all will instantiate the list for you. And you are supposed to read back what you put on that. So a more complicated example now. So we have put the team and the countries in the database, and now we're going to put the members. And if you know Panda and Panda Data Frame, Tanker also support it. So the example before, it was with a list of tuples, but it can be also a data frame that holds your content. So here we have all our members, their country, code, and teams. And so to write them, what we give now, so we have to say to Tanker, so before that we were giving a list, so the position of the name of the column was enough. So when we did that, it was implicit that the first argument is the name and the second one is the country. So it's the position that gives you the what is what. Here, what we give is a dictionary, and when you give a dictionary, the Tanker will get the name here from the data frame, country, etc. You can also give a list of dictionary instead of a data frame, and it will work the same. So in this case, we say, okay, name is going to be the name of our members. The country here is the name of the country of the team of the members. So Tanker will have to join all those things to know which team and which country is linked to, and then the team itself. So for the first example, we're gonna have Bob in blue team in Belgium. And in this case, it's a tricky one because, as you remember, here Tanker has to say, okay, this member is in this team. But it's not enough to say it's the blue team or the red team because we have several blue teams in different countries. And we have the index on the team, which is on both columns, on the name and the country itself. So we have to give those two information. For Tanker to know which team exactly it is and discover the right ID for the database, you have to give the country. So it's a couple of the team name and the country name that gives the team exactly. But beside that, it's going to work. It's not more complicated. So once it's written, you can read back the results. Just before I show you how to read a list, you can also, after read, call .df, and this would give you a data frame back. And so we get back a data frame with all the results. And now, if we check the database, we see that it was, I think, Bob and Trudy. So those two are in the blue team, but the first one is a Belgian team, and the other one is a France team. So it's nice to have. So when you read stuff from the database, you can read everything if you want, but most of the time you want to filter stuff. And how the filter works are based on S expression. So if you know Lisp, you already know that. The S of expression is symbolic expression. All it does, the main advantage of S expression is that it's super easy to parse. So it's super easy to have a small language to express the filters. So in this case, we want only team. We want only members whose team is in country Belgium. So we say we want to read the member table, and we want the country of the member. And this filter says the country must be Belgium. So the first argument of read is a filter, and when we read back from the table, we have the list of team. No. Yeah, I think the example is wrong. Yeah, it should be team.name here, because we have team as a result and not countries. But anyway, this is how it works behind the back. So if you do this call, Tanker will generate that for you. So implicitly, each time you do a dot, you will have to you will generate a join in your SQL query. Yeah, and as I said, we are reading team name. I don't know why that. So we select the name of the team, 4 member, and then we join on team, and then we join on country. And then we said the country name should be Belgium. So it's quite easy. And you can, here it's a small example, we have 3 tables. So this is the most complex join we can do, but we have production server with 60 tables, and sometimes the query it's 10 joins and something like that. And Tanker will try to reuse some joins if possible. And we'll avoid to do stupid stuff if you have diamond queries. So if you have several joins that go through the same table but through different paths. Anyway, so if you want a more complex query, so here we have also an S expression. So I forgot to give some details. It's quite easy. All you have to know is that it's an operator, left operand and right operand. So it's like team name equal blue. And so here we want blue team or a member code in 02. And then we have the member with those members. Yes. So blue team are those two and 01 are those two. Anyway. And here are the current operator. So I show or and equal in, but you have not equal, bigger, smaller, not is not, null, not null, quite handy, etc. I'm not sure I have everything, but until now I haven't yet needed something else. So this is quite easy until now, but the big problem when you work with external data is that you have also to update it, you have to maintain them. So this is our new data. So let's say we have scrapped a website or downloaded something. So 2D has disappeared, and Dan is now in a red team in Belgium. It was in Holland. And the code is more or less the same. So you have the same view that define how you map this data to the database. You write members, but the new version of members. And by default, write will only try to insert and update, but won't try to delete. So purge here, you say to Tanker, okay, if a line is missing, delete it also. So in our example, TrueD is missing, so the purge argument will say remove TrueD from the database. If not, only Dan is updated. But you can also say insert and update as argument. So by default they are true, but you can say insert equal false. So I will write data to my database, but I want only the updates, and you don't insert the stuff. Okay, and then when we read back stuff, TrueD has disappeared, and now Dan is in the Red Belgium team. So quickly, other features that I don't cover it, I haven't covered. So ACL, access control list, you can define filters that are automatically enforced for you all the time. It's mainly handy if you have a multi-user application and you want to say this user can update this table or this line in those tables, but not in connection pooling. So you can create a lot of connection, but Tanker maintain a pool so you don't overload the database. You can work with multi-thread and nested context. So if you want to connect it with two databases and transfer data from one to the other, it's going to work. This is not a feature, but a limitation. Because we use temporary table, SQLite, as soon as you create a table, even a temporary one, create a commit for you. So when you work with SQLite, you're going to have transaction as soon as you start to write. If you do one write, it's not a big issue, but if you do several writes, a few writes can be committed for you, and then you wonder what's happening. Yeah, there is support for more which way to pass argument. You can also give default value in your database, so you can have a timestamp with a default value equal no, and each time you insert stuff, it's going to be no. And there is an explicit delete method on view. And a short roadmap. So currently, foreign key resolution is done in Python. So before writing, we have to resolve foreign key in Python. So we have to know Belgium is ID1, France is ID2. So it can be an issue with big tables. Yeah, this is difficult to explain. Now, Postgres support upsert. So we may use, I think there is a way to use it and avoid temporary table, I think. So the upsert PostgreSQL is insert and on-conflict update, which is quite handy. Maybe I could add more type of column. So currently we can create column of varchar, timestamp, and all the other one. We may need more. There is no way to detect conflict. So if you read a bunch of data from the database, somebody update them meanwhile, and then you want to write back, you're gonna erase everything you did, or you don't know. Have more. So currently we insert or update. or we delete if something is missing. We may need to, I already see some application to trigger something else than a deletion when a record disappears. Yeah, and have filter when we write. So if you have a filter when you write, first you know you won't overwrite something you don't expect to write, but you won't also delete something you don't want to delete. Yeah. And that's all. And I give some link. So I use RST2PDF for the presentation. It's an old one, but a good one. It's a nice library. And some links about stuff I taught. Voilà. Any question? Yes. No, currently there is no way to load the information from an existing database. But it could be done because I already do that, because I have to know when I create a column, I have to know if it's already there or if it's a new column to create. So most of the code is there to do that. But yeah, I haven't got the need yet. Yes? Okay. Yeah. Sí.